My dear students, good morning. How are you feeling at home? Due to this pandemic disease, it is not becoming possible for us to gather together in the institute for live classroom teaching. However, our management has made all the arrangements by LMS system, that is learning management system, so as to provide the teaching, online teaching to our students for their progress and their career. You need not have to worry. This is not in our hands. Certain things are dictated by nature. We are also feeling sad and bad for this disease of COVID 19. Be bold enough and courage enough and keep in touch with the study at home itself. We will be here to help out you by teaching through LMS, Learning Management System. Myself, B.S. Venkatesh Murthy, Assistant Professor working in the Civil Engineering Department, SRES Sanjeevani College of Engineering, Kopargaon. Today this is the introduction class. First and foremost, I would like to acknowledge and thankful to Professor Satish G. Taji, Assistant Professor, Civil Engineering Department, my colleague, SRES Sanjeevani College of Engineering, Kopargaon, has helped in providing these slides which he has prepared for me also for online teaching. I am very much thankful to him. Before I continue, I should acknowledge. I am acknowledging it. In this today's class, no more slides will be on. Just we shall have a bird view of the syllabus content after knowing about the scheme of teaching and scheme of examination. As you are aware, teaching scheme will be 4 hours per week for theory lectures and 2 hours per week for term work that will be carried out in the due course of time by looking into the changes which are happening in the present scenario. However, the study should not be get hampered. That's why this online teaching scheme is provided by our management. We should be thankful to them and happy about the system which they have provided. Now coming to the exam scheme, as you are aware, there will be in-sem exam for 30 marks, 1 hour duration, end semester exam for 70 marks, that will be 2.5 hours for this subject, and there will be term work, but that does not carry any marks, only oral 50 marks. Okay. These subjects, fluid mechanics 2, consist of 6 units. First unit, fluid flow around submerged objects. This is the A part. B part of unit 1 is unsteady flow. Second unit, A part, introduction to open channel flow. B part, depth energy relationships in open channel flow. Coming to third unit, A, uniform flow in open channels. B, hydraulic jump. Unit 4, A part, impact of jet. B, centrifugal pumps. Unit 5A, hydropower generation. B, performance of hydraulic turbines. Unit 6A, gradually varied flow in open channels. B, gradually varied flow computations. Before we go to the first unit, little bit detail about the syllabus content. we will see certain textbooks that can be referred for your study period. Hydraulics and Fluid Mechanics by P.N. Modi and S.M. Seth, publishers, Standard Book House. Second, Open Channel Flow by K. Subramanya, THM publication, third edition. Third book could be Open Channel Flow by K.G. Rangaraju, Tata McGraw-Hill Publications. Next, a textbook of fluid mechanics and machinery by Bansal. Those who are more interested in referring the foreign author book, Fluid Mechanics by White, McGraw-Hill Publication. So of course all these books which just now told, about half a dozen, are available in our library, plenty in number, and you can refer the different courses material like NPTEL, Coursera, and other courses which provides information about fluid mechanics too. You can search on internet, and we will also help you as the time elapses. We will keep on giving you some more reference books, journals, and e-material. Anyway, we are uploading our notes which have been prepared, handwritten notes, or maybe some Xerox copies of good reference material as far as the syllabus is concerned. Only the matter lies with you is keen interest and dedication towards your studies, especially in this lockdown period of COVID-19. So, we shall see what are all the syllabus content of Unit 1, which will be started from next class. Fluid flow around submerged objects. For example, you are moving in a bicycle or a car on road. There is a heavy wind. What you feel? You feel that you are dragging back. Why? Because of the air, which is nothing but a fluid, which is applying force on the body. That's why whenever any subject is submerged in a fluid, whether body is in motion or fluid is in motion, fluid will exert some force on the body that will be exerted as a resultant force. So therefore, here we have to see various practical examples which are involved in such submerged bodies which are surrounded by the fluid. What is understood by drag and lift because of this force acting upon the submerged body? Drag component, lift component. What is understood by drag coefficient, lift coefficient? And drag on cylinder, drag on sphere, that is three-dimensional bodies. What is understood by Karman vertex street or Karman vertex trial street? Then the effect of lift on submerged bodies like flat plate, cylinder, sphere, aerofoil, etc. We have to see the effect of lift, coefficient of lift, and what is the relationship, how it varies, what are the factors influencing, etc. should be thoroughly studied along with the neat suitable sketches. Only thing is the interest should be shown in understanding the concepts. If basic concepts are clear in the teaching classroom or online teaching, it will become easy for you to work out during study period at home. If not, even though you have a good textbook, it would become little difficult. That's why we are just guiding you how you can learn more and more in short time. Okay. Now, what is the Magnus effect? Magnus is the physicist. In the year 1854, he has investigated when a cylinder is allowed to rotate or rotation is applied in the uniform flow of fluid, there will be a force, lift force developed. That phenomena of developing of the lift force due to the circulation imparted on the cylinder in an uniform fluid medium is known as Magnus effect. That also should be studied. Then Kutta-Joukowsky theorem and equation, which is also related to the lift on cylinder. That formula or application of Kutta-Joukowsky equation is applicable for all such bodies like aerofoil, propellers, pumps, etc. How this equation can be made use of to find out the lift components on such bodies. And then we have to study what is the relationship between CL and CD after performing practicals in the laboratory in a wind tunnel for any aspect ratio of aerofoil or any other body. Then what is polar diagram? What is understood by stall point? What is stalling angle? What are the characteristics of an aerofoil? What is the lift component on an aerofoil using Kutta-Joukowsky theorem or equation. So this is a brief introductory class, small session. Thank you for patient listening. We will continue with the actual lesson from next class. Once again, I acknowledge Professor Satish G. Taji, Assistant Professor, Civil Engineering Department, and he is my colleague, SRES Sanjeevani College of Engineering, Kopargan, for providing these slides which will be used from henceforth classes on online teaching through LMS, Learning Managing System. So we will be uploading whatever the information you require. Time to time we will be uploading little stuff we will be providing to you. You eat it and try to digest it so that you can enhance your knowledge and you can be in progress of your studies. Don't desperate about this COVID-19. Best of luck to one and all. Thank you.